Hello, everyone.
Awesome, there we go. All right, fantastic. Well, I'm excited to introduce Ketan here, who's going to be talking to us about end-of-day workflows for complex financial processes. Sounds like something where we don't want to be making mistakes.
Okay, yes.
All right, let's give him a warm round of applause here.
All right. Thank you, everyone. Thanks for this opportunity. So I'll get started. I'll be talking about, as Adam said, the end-of-day workflows for complex financial processes. So some introduction about me. I've been back-end programmer and working with multiple startups and product enterprises. This is my Twitter handle. The use case I'm going to talk about is the product I worked recently. It's Flex for B2B payments and spend management. So in a fintech, at the end of the day, there are a lot of transactions and data movements and uh, maker checker flows. Also, lot of reconciliation things, including multi-party settlement. So all these things are typically modeled as traditionally bad jobs, and if we invert them into stateful workflows, a lot of things become very easy in terms of simplicity, in terms of implementation, configurability, as well as the maintenance, which is very important thing. I want to highlight something. We as a team were pretty new to the functional side of things, mostly imperative and object-oriented programming. So we ended up using most of the simple examples from Zero documentation, and that did serve uh, us to moderate success. And there are some few things we need to learn on the way. But this talk is about how did we something like perspective from someone who is coming from the imperative world, and how did we end up modeling this thing, or leveraging Zero to simplify things for the business use cases at hand. So to give some context, typically like the credit card statement, we are providing the same facility to businesses, small, medium businesses. So they would have end customers, departments, users, and their employees would be buying, let's say, home office equipment or maybe tickets to functional Scala conference. And at the end of this billing period, there would be bill statement and also due dates, something like some grace period, and then customers would be paying. They have to pay this money. So the workflows are applicable for a lot of situations, but for this talk, I'm just restricting it to billing scenarios. So on any day, there are primary workflows. I want to make sure, okay, is this a billing day for this customer? I want to generate a bill. If it is due tomorrow, want to send out a reminder, change status, or apply some interest and charges. So this is pretty straightforward thing. Uh, and when we model this as a workflow, within each workflow, there would be multiple steps, and these steps are basically interactions with the external world. It could be RPC calls, database calls, or in some cases, some process forking, generating PDF and other things. So this is how we, let's say, a very bare bones representation of a workflow. Now, I'll just go over the overview. How did we arrive at this solution? The primary thing, what you see at the top is the workflow state, which was externalized. And the Zero is being just used as an orchestrator. It is running as a forever loop, and basically it could be interrupted based on the state of the all running workflows. So on any day, it would go to a repository and specific service and figure out what are the jobs I need to do at this point of time, and it would gather that, and basically depending upon the different workflow types, it is going to generate a payload for them, and then each workflow is a template. It's going to run from start to finish, and as a part of that transition, it is going to execute some or invoke some services, or maybe invoke some call to streaming service, and there would be some external actors which would be also changing the state. So this way, my orchestrator is only going to figure out is there anything pending in the running jobs, and the whatever workflows are being completed, they are going to exclude themselves out. Now, in some situations, these calls to services may fail, network partition or other issues. In those situations, being a loop, it is going to retry again, but I don't want to try this eternally. So I can have configurable options that, okay, I don't want to try more than few times, or based on the response I get from a service. This could be even the service is available, but it's not able to perform the job. So all this is captured in the workflow definition, like a new bill or overdue, and this is again going to be the elaborate multi-step process. So each workflow template is kind of series of steps, and there would be n number of types of workflows, and the orchestrator is just going to configure and generate a payload for them and just run them in a loop. So this is a very simple representation of, let's say, inverting the batch jobs to a more presentable or understandable format. That is something which we ended up doing. Now, the code I'm going to show is pretty straightforward. I think it would be more, very simple. Whoever has worked on Zero. So this was like first few examples what we see on Zero. But I'll just say that all these workflows are, as I said earlier, these are mutually exclusive. And even though we have fixed number of times, but once we have thousands of customers, it could result into multiple runs and on any day. And the one thing we did here is the state management is externalized, and that allows us to do the coordination between different actors and resume and retry kind of a thing, which is, I would say, preliminary, but it serves the purpose, and it's still better representation than the bad job kind of a framework. So this is very simple orchestrator. It's the workflow loop is going to run continuously. It would get interrupted when there's nothing else to process, and once all the job is done, it's going to sleep till the next day. And the state is gathered at the bottom, something like I'll fetch all the applicable events for this type of workflows, and it's going to take a diff inside my 5 workflows. Okay, from all the events, which of them are still not in a final state, so I just want to run them again and again. And there's some sleep here that the once we, since there's a coordination involved, we just want to allow streaming services or messaging, something like sending messages to Twilio, send mail kind of a thing. So that will externally modify the state based on that service to the state repository, and then it would resume from this place onwards. So this is kind of a very simple example, but this allowed us to segregate different workflows and just fire them. And uh, so this, beyond this orchestrator, the individual workflows are the one other important thing is some of these services could be generating a lot of PDF statements or and consuming a lot of resources. So simple thing like restricting to number of fibers that I just want to have them run over 10 fibers, and that allows me to optimally use the configured resources. And once I don't have any more pending jobs, it's going to fail and interrupt my workflow loop. So this is on a high level, and uh, each within each let's say the new build workflow, each stage is kind of it's going to do execute all these operations one by one in that sequence, and that's basically uh, the how we ended up using Geo. So this is nothing. I mean, this is fairly easy, but if you think about applying the workflow as a conceptual model and modeling your this background jobs or something like EOD jobs in this way, it ended up solving a lot of issues for the whole team. And typically, this kind of a work is not, primary core part of your functionality or core part of your product. So this is going to be internally consumed, and this having this kind of a system in place allows us to add new workflows to modification and also simple testability in your staging environment. So as I said, this is something being new to Zero ecosystem. We we got introduced to simple concept, and it helped us to raise a level of abstraction, and the code structure and overall understanding of these things is has become simpler. Multiple developers can write their own templates running from start to finish, and all the existing logic in terms of the individual steps that is still being reused. So this was win-win for all this situation, and these are the very simple things we ended up using, nothing complex. Uh, yeah. So I know there are some other uh, open source frameworks available. One of them, ZeroFlow. When we started, that was pretty new, and we didn't have any in-house experience and the deadline. So, but typically when you say about workflows, there has to be check for each step, that once you run that step, at the end of that, whether it is successful or failed, so that has to be there, and something like compensating transaction. So this kind of a terminology or all these concepts are pretty common across all these frameworks. So uh, uh, ZeroFlow, once it is being I think the documentation is lacking, but when I went through a couple of Symposium calls, it is very interesting idea, and having a first class framework to support this would be very easy, and maybe the next step would be in a distributed environment fashion, or distributed persistence kind of a fashion, that I can recover from failure of a single node in case of workflow execution. So that's all I had to share, and thanks for the whole community. This is something I'm talking first time to the functional programmers. So I'm really grateful for this opportunity. Thank you.
Thank you so much. I'm not sure how much the audio was coming through, but you were getting a very warm round of applause there. So thank you so much for
Okay.
that talk.
Okay. I'd like to, if there are any questions, at least I'll try to answer. I think this was a kind of a tie between, earlier we had the Scala test talk, and so I thought maybe mine would be the lowest or denominator kind of thing, but let's see.
Yeah, you were very efficient in your presentation. So yeah, I think we do have a good amount of time here for
Yeah, yeah.
questions, answers. So maybe I'll first give the opportunity to anyone in the room here in London. Any questions you want to ask about this? How about on Discord? I see lots of claps, which is great. Any questions? Sounds like Pierre may have a question, but I'm not sure if it's about this or something else. We'll give him a minute as well as anyone else here. Kit asks, what font did you use?
Nah, even I don't remember. It's like whatever default template.
How dare you not know the font? That's the most important thing. Okay, we
So
have one.
maybe a couple of things I learned for last 2 days, just for the So one of your talks said that okay, the dissolution is very important. So that did stick to yeah, that is very helpful learning. And what we saw today, the mad skills from Kit, that was something out of the world. So he made that presentation to I mean he completed it on the time. So yeah, that is something a very high bar, and I'm very excited to be part of community and learn and get to that level. Thank you.
Well, it's great to have you be a part of the community, and yeah, I think the issues that you're starting to raise about how we have these types of workflows and how we do this is one that I think we're going to be spending more time on over the coming years, and I agree is an area that's ripe for both a solution and eventually, hopefully, dissolving part of these problems where just some of this stuff gets automatically taken care of for us. But okay, I think we've got some actual questions here. So from Ahmad, we have a question of how are you handling monitoring of failures inside your workflows?
So that was based on the existing solution in terms of all these events are modeled in a key value and structured format inside DynamoDB, and there's a streaming on top of that, and then there's a basically that would be consuming from the lambda itself, and then it would figure out okay, but this is something not I would say first class in terms of within zero code, but this is a compensatory thing that okay, are we running beyond, I mean, the loop is continuously being run, or I'm hitting the same transaction again and again. So this was the complexity of these things is pretty limited. Also, the number of APIs being invoked are pretty straightforward in terms of just gate calls. So in actual workflow or in real world, you want to make sure that when you're making these calls, those have to be really idempotent calls. Otherwise, it is going to end up changing the state of things, and that is something a disaster. So and those were conscious drawbacks we agreed to, but this was something which was like remodeled the original batch jobs to get to a state where we can add and use this blueprint to apply to different set of workflows. So these are like around 7 8 kind of a things. So yeah, we yeah, we don't have any deliberate in place or in zero first handling for workflow. uh, Basically, being a workflow orchestrator, it is not managing that. It is basically the state is externalized, and then you are watching that state to make those decisions, how whether it has failed, and I want to recover from that.
And could you step back for 1 second, just talk a little more about what a compensating transaction is for folks who may not be familiar with that term?
So let's say I'm going from A to B to C as different steps, and when I'm at step B, and if it fails, I want to basically make sure that as part of whatever side effect or whatever things I ended up modifying, that I have to roll back. So this in some cases when you're working as a part of a workflow, you may be changing things at multiple places, maybe a DB record and also invoking some API. So you want to ensure that you can resume or you want to retry. So you want to retry from the original state. So uh, in a distributed system, that is a if you it's basically rollback. If you can't complete that to the end state, you want to reach to the prior state.
Great, thank you. And I think another question that is related to that, Phil Allen asks, sometimes we need to restart batches, want to start from some high watermark. Any thoughts on a general way to support that?
High watermark. So, so not sure I'm getting the context from the high watermark with respect to workflows. So, uh, let me. The high watermark as a concept is like the distributed system. It's like I just want to how is that applicable to workflows that the use case I am presenting is fairly straightforward. There's a lot of work to be done beyond this to have it used as a mature framework. But if there's any follow-up discussion on Discord on explaining that question, I can at least make an attempt.
Yeah, I think the idea would be just if you need to do 100 things and you have a failure when you've done 90 of those things, you'd like to kind of have, if you're smart, maybe have committed on the 80th thing or whatever the number is, so that when you start over, you start from 81 and okay, you only have to redo 10, or maybe you only have to redo 5 versus
Okay.
having to redo all of
So
them.
Okay, so maybe my interpretation is basically when I talked about those four workflows. Let's say that as an example, I have let's say few thousand customers, and on any day, let's say I want to generate few hundred bills and few hundred notifications, and as a aggregate it is something in thousands. So all these are mutually exclusive because they do have their own context. And let's say for initial 60-70% of transactions, everything was available and was working okay. So whatever completed transactions, workflows, individual workflow instances, they are completed, they would exclude themselves out from the next set of execution because they have reached the terminal state. The cycle has been completed. And post those, let's say there's a availability issue, not reaching out to specific service, and then it would stall. And let's say that was intermittent failure, it recovers back. So next time I'm going to have only the pending workflow instances. So the way this is, I mean, the transactional aspect of that is just limited to a single workflow instance because it is going to move through individual states, and that state is externalized, and that state is applicable for only that specific customer or account. So in a way, that isolation is already there, and maybe because of our domain, that is helping here. But in a general sense, uh, that would be yeah, we would need to know more details to answer this question. But in this case, whatever workflow instances have reached the terminal state, they are going to exclude themselves out from the next set of run. And in some cases, we can't recover from failure, so there would be premature termination of that particular workflow instance, and everything gets captured. And then eventually, we would say that maybe 20% of things didn't complete, and then we have a mechanism to invoke them through API for retrial once we recovered from the actual downstream service failure. And that's where the other thing, whenever this let's say the orchestrator completes its flow for the day, it's going to trigger something which is going to go through all those events in DynamoDB, and understand whether all the workflow instances have reached and none of them are prematurely terminated. So if we see that situation, it's going to raise alert, and that is simply because of serverless pipeline. But in actual, maybe this has to be first class implementation but this is yeah, this is basically what we ended up using, multiple things to solve the business use case. I hope I answered at least some parts of your queries, and yeah.
No, thank you so much for answering that. We got one more question here from John Luke. I don't know if this is John Luke Picard, but he asks, is the application always up? How do you manage trade-off between operation costs and performance?
Yes, this application is yeah, this application is always up. There are two primary things for that. One is at any specific scheduled intervals or scheduled time, it is going to run this workflow. In some cases, I want to externally trigger them. There's a customer support ticket that there's some issue with one of the billing statement and they want to generate a new statement. So I just want to rerun the whole workflow. So there would be other system which would be doing a compensatory transaction. It's not exactly compensatory transaction with respect to this, but it is going to do the adjustment and there's provision to re-trigger the specific instance of the workflow. So for those reasons, this system has to be running the whole day. I understand the concept. It could be solved through scheduling, and a lot of containers do allow that. So, but in case of perform the cost optimization, we are running this on a very low resource, not much, something like 8 core thing, running few hundred unique workflow instances in those 5-7 minute intervals and few hundred over the period of the other whole day remaining time. So by doing the limiting number of fibers in parallel, we are anyways resorting to a mechanism that it may be delayed a bit, but it's not going to get issues because of the resource starving, or because I'm generating a lot of PDF, let's say hundreds of PDF simultaneously. That's going to through external something. So that is going to be a memory hogging thing because it's a process forking and yeah. So it is a trade-off in terms of we want to run that whole day, but maybe the whole day we don't need those many resources. So if we chose something which is going to be good enough and still control the peak load by using the parallelization, the limited parent fibers as a parameter.
Okay, great. Well, I think we'll wrap it up there. Thank you again so much for taking the time to share this with us.
Thank you for the opportunity. Thank you, audience.